Welcome to a new test and teardown video. This time it's a Wavetek model 184 5 megahertz sweep generator, and this one is quite feature packed. We also got a huge frequency range from millihertz, and I think it's actually going, as you can see here, when you dial this all the way down, 0.05 times 1 millihertz. Oy, 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 this is slow. And then of course we can go all the way to megahertz times 5. So that will be our 5 megahertz. We can adjust the sweep width, sweep time, sweep modes, manual trig. We can do all sorts of continuous or trigged. Some of these are really hard to move, so I don't dare to try and do it so much before I open and clean them and lubricate them a little bit, because you can crack the knobs and I don't want to do that. So I better inspect and see what is the state of this thing. It is quite old, and the fun thing is I got model 185, 187, and I don't know how many more Waveteks. I got quite a lot of Wavetek's in my collection. So if you're into Wavetek signal generators, please go to my video section and find some more good stuff. So here at the back we can see the model number 184 again and the serial number, a little bit about fuse size, and here we got the voltage selector. It's a little bit funny, this high low and 230. So this is the inside top view, and as always so nice and beautiful with all the wires here to mains input and mains voltage selection. The on-off switch is also correctly located far away from everything, so all this can be kept away from all the sensitive analog circuits. So I kind of like that. And then our secondary side from the transformer goes here. So I expect we'll have the power supply, all the rest, or all the parts here to the back, that will be power supply stuff. That will be the sweep control pots and sweeps. So yes, exactly, all this sweep stuff. And the frequency setting here is just a regular potentiometer, and there is a little lamp up here. So this is a classic Wavetek. I mean, I've seen many other signal generators with a power indicator right there, so I kind of like that. And here is the bottom. It's a little bit funny how all the components, they point this way. Well, that will be the, yes, exactly, the output. So this will be the output amplifier. Power supply parts here at the back. And I really like the way they are writing here on the silk screen. Where is this? Where is that? What are we doing? Really nice. They didn't do this on all the Waveteks. Some of them there's absolutely no information anywhere. You need to read in the entire manual and figure stuff out. Yeah, I need to clean some of those switches so they're not so tough to operate. Oh, this is tough. There's also quite a lot of decks. But do we find any leaked capacitors anywhere? That is the big question. And I don't see any blown up resistors or transistors or anything. So that is good. And I think we should just proceed with a little bit of cleaning and then the power up. And this is the first power on. Of course, I want to test the on-off switch. So we got output, and the lamp. That is funny. That came so much later. How is that possible? So this will be symmetry. Okay, this is good. We got a little bit with triggering. Nice, beautiful. Oh, we can. So this is the symmetry also in sine wave, but you can just click. Nope. So maybe this switch is not working. I would expect this one should give. Okay, here we go. What? Hello? Okay. So we need to massage all the features, and here we go. There you have it. Very, very good. I'm still investigating the different features of this unit, and what you see here is the TTL output. Look at that. We got 1 point something volts offset, and it's just not giving you just a few hundred millivolts of pulses. So now we know this pulse out TTL here is not working. So maybe I will be able to find a schematic and figure that out. And then I will of course try and play with the different features like sweep. So I think if we go to sweep and then sweep with. So sweep is here in stop. So let's take continuous sweep, and there you have it. And this is the sweep time, 100 seconds. It's super slow. We can go faster and faster and faster, and so here is our sweep. A few seconds like that, so we can see what's going on, and then we can how much, a lot, or only a very little bit. That is pretty good. Let's try and take the sweep start. Then you have no. Why did that not? Oh, gated or something maybe. No. So manual trick. No response. Maybe this switch is not working. I'll of course try and put something into the trick and see if that works. So just to learn a little bit more about how things works in here, let's try and put in a pulse, a 1 hertz pulse into the trig input. So that means the waveform, the 1 kilohertz waveform in trigged mode will give us a 1 pulse every time there is a trig input. They're very useful features for all sorts of things. And so now we have proven trig input works. I think it's also the same input that is used for sweep, but I don't really know. But voltage control input is just for sweep like that, right? But if you're using the internal sweeper, and then we go into continuous sweep, see, we have sweep. So this is the sweep time. I was hoping to start this on a external, and that just don't happen. So maybe I'm doing something wrong, or maybe I need the manual. Damn it. So that's just how it is. Sometimes I just don't know how things are supposed to work as well. But that is not working the way I imagined it would work. Oh, we got another really good news here. This is the voltage control input, and here we go. My 1 Hertz input is now a sine wave, and as you see, it's really nice and fantastic. I totally love it. Voltage control, yes. I found the manual, and the first page in the manual shows a completely different unit. Look, mine is in a nice, beautiful metal case with big, nice metal handles, but this is not the model they show in the manual. So I think my model here is a little bit older than the manual. So that's a little bit funny, isn't it? I found a block diagram in the manual that explains the trigger input. And if you carefully inspect here the block diagram, you will see the trigger input is not in any possible way connected to the sweep system. So that means trig input can of course not start or stop or handle anything in the sweep. As I previously had the idea that was the way it's supposed to be working. So it is, of course, not. So there's nothing wrong with any of those things. But I also complained about the TTL output. So here's the TTL output we see up here. There is a big offset, and then we don't really have a lot of signal, so there's something wrong. So in the schematic, I find, of course, this synchronization output, and there is an IC, the 7400, a NAND gate chip, and I'll try and locate this one and first maybe just measure the DC supply voltages for this chip. So that's easy. Here is IC7. It's easy to see right there. And this is the 7400 pulse generator. How easy is that? And I just checked. We got 5 volts on this chip. Let's try and change it. So I just put in a new chip. And look at that. Now my TTL output is good and fine. So I bet the output from this chip to the BNC connector wasn't protected good enough for ESD or something like that. Overloads will probably blow this, I don't know, whatever. But it's in a nice socket, so that was easy to repair. So other than that, I don't really find anything else to complain about or to poke around with in this unit. It's just working really good. And here is the highest possible frequency, 5 megahertz. And then I do see a little bit of decreased amplitude in the sine wave, and also we now see the trigger output is a little bit slow on the edges, obviously. So I think I will call it a day. Thank you very much for watching. Hope to see you soon again. Bye bye.